Hello everyone, welcome to Easy Chemistry by Praveen. So last video we explained about the Luther-Meyer annual and classification. Now you can see the Mendeleev periodic classification. So Mendeleev periodic table classifications. First I want to tell you that whatever the periodic table right now we are seeing, that is the extended periodic table or periodic classification of the Mendeleev. Mendeleev that time no only 63 elements were there. 63 elements was there. So based upon the 63 elements only he made the one periodic table. He classified the 63 elements. So he's also like previous scientist. He also based on the increasing order of their atomic mass. Increasing the atomic mass. This Mendeleev also studied physical properties and chemical properties. But when compared to the other scientist, he has given the more importance to the chemical properties he has given. So let us say that, for example, I have taken that reactions with what is meant by chemical properties. Chemical properties is nothing but the reactions of the elements, particularly with oxygen, with hydrogen, with the different elements. So for example, if I take something like elements like M, N, O, I'm taking like a instead of M and O, I'm taking like the three elements like A, B, C, three elements I'm taking. For example, A reacting with the oxygen, it will form the AO. Oxides it is forming. With the hydrogen it is forming AH it is forming. For example, when the oxygen is reacting with the B element, so it is forming like a B2O it is forming. When in the C element is reacting with the oxygen it is forming CO it is forming. And with the hydrogen it is forming like a BH it is forming. So C element react with the hydrogen it is forming the CH2 it is forming. So nothing but these are the formulas. So 63 elements he done the same experiment. He studied the physical properties. 63 elements he studied the chemical properties he studied. So he observed the one great thing he observed. So based upon that is only his classification is actually made. His periodic table he made based upon this point only. So once you observe here, you can notice the one similar points. You can once you observe here, you can notice a similar point. So for example, A element forming the oxide is AO, C element forming the oxide is CO. Nothing but A element oxidation state is +2. Nothing but you can say that valence is 2. A element valence is 2. C element valency is also 2. B element's valency is a 1. That means what? When the valence is same, formula is same. When the formula is same, automatically chemical properties will be depends upon the formula. Chemical properties depends upon the valency. So then he made A element and C element based upon the increasing order he kept in a similar group. Another B along with the some other element he kept in the another group. So this is the very good he has all the 63 elements he arranged like this only he arranged. So here he is the first scientist who was introduced to the word like call it as a periods and groups. Periods and groups. Periods, the horizontal rows, whatever the horizontal rows is there, then he considered as a periods. That time he was in periodic table like 7 periods were there. Like first period, it is represented with the Arabic words, Arabic numbers 1 2 3 4 5 6 and 7. When it comes to the groups, like it is like a vertical column. It is like a vertical columns. That time vertical columns like 9 vertical columns were there. I will explain how he made it as a 18 also. So vertical columns he is represented with the Romans, first group and second group and third group and fourth group and fifth, sixth, seventh, eighth and zero group element. So here in the zero group he kept like a noble gases. He made it as a noble gases. So now he can say that no, so based upon the oxidation state, based upon the valence, he arranged the atomic he arranged the Mendeleev periodic table. So here you can see that no, one simple thing, one two words we should learn in this, that is called as a diagonal relationship. Diagonal relationship. So what is meant by diagonal relationship? So for example, you can see lithium, sodium, potassium. He kept in the same similar group. He kept. Why? Because their chemical properties same. Their of course, increasing order of the atomic mass, chemical properties same in the sense they are forming with the same chemical reactions. So like this, you can see that no, beryllium and the magnesium, another group. Okay, next one you can see that no, boron, aluminum, it is like a another group. Next one, carbon, silicon, this is like a another group. Here he observed that something, some relationship he observed diagonally. So for example, here lithium, you can see lithium atomic size is very small. Lithium atomic size is very small. After the lithium, sodium atomic size is more. You know that when the top to bottom atomic number is increasing, sorry, atomic mass is increasing, automatically size is also increases. So here what will happen, from when compared to the sodium, magnesium, so this is like a periods, when we are going from the period from left to right, atomic size is decreasing. So when compared to the beryllium, when compared to the sodium, magnesium size is very small. When compared to the magnesium, aluminum size is very small. In this time what happened, the size of the magnesium and size of the lithium are like a approximately similar. So automatically some properties are matching. This means lithium and magnesium properties are matching. Like same thing, beryllium and aluminum properties also are matching, and boron and silicon properties also something matching, some relationship is there. So that relationship is also diagonal relationship. So that's why we are calling it as a diagonal relationships we are calling. So next one you can see that no, another word we have to learn here, that is called it as a bridge element. So generally bridge element, third period elements, we are calling it as a bridge element we are calling. So Mendeleev the arranged the elements like a in a eight groups he arranged, like for example first group, like second group, next one third group, next one fourth group, fifth group, sixth group, seventh group, eighth element I will tell you later. So seventh group he arranged. So automatically how it will happen, hydrogen period 1, next one is called as a lithium period 2, next one sodium like a period 3. After the sodium, potassium is there. But here what happened, along with the potassium, he kept the copper also, he kept in the same group only. Two elements he kept in the same group only, periodic table. After that no, along with the rubidium, silver also he kept in the same group. Like this, after the third period, fourth period onwards, he kept the two elements in some groups he kept. So generally people after publishing of his periodic table, people start questioning that no, potassium and copper you kept in the same group, how? So to avoid this confusion, he also got the some doubt. Actually he got the doubt in the sense potassium and copper properties are similar. He thought that no, properties are similar, but because potassium valence is 1, copper valence of course it show like a plus 1 will show and plus 2 will show. Same thing with the rubidium also valence is plus 1, silver also will show the plus 1 will show and plus 2 will show. That's why based upon the valency, based upon the chemical properties, he kept the two elements one side. But no, that is completely wrong. He couldn't he should not kept the two elements in the same way. So that's why he made the first group, he made into two subgroup, first A and first B. Like that, second A, second B, third A and third B. It extended into a seventh A, seventh B, like that. So automatically what happened? Hydrogen, lithium, sodium. After the sodium, again group is subgroup. Groups start dividing into after the sodium. That means what? Here also after the sodium. That means what? In which period? Third period onwards, groups one group divided into subgroup. Here also seventh A and seventh B, when they are divided into two subgroups after the third period. So third period, the third period elements, whatever the third periods are made there, they act as a bridge between the main group and subgroup. That's why this is called it as a bridge element. Which periods we are calling? Third period we are calling it as a bridge elements we are calling. So like this, if you count here 2, here 2, 4, 5, 6, here also, here also you can see every group he made it into two subgroup, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. That means what? 1 to 7 group Totally he had 14 groups are there with including of the subgroups. And in the 18th group what he made, he kept the three elements iron, cobalt, nickel into the three subgroups. So 14 plus three subgroups plus zero group elements. So totally how many groups are there? 18 groups are there. So totally he has a 18 groups he made into the his periodic table. So thank you for watching this video. Next video I will explain about the merits of the Mendeleev periodic table.